Stand up so you know I'm here. Hi, my name is Bill Sempf. I'm the 1 o'clock talk. You're all going to have carb coma in about 30 minutes and be asleep, but that's okay. So I'm from Columbus. Don't hold it against me. Columbus, Ohio, not Columbus, North Carolina. Pleasure to be here. Been trying to get here for 4 years. Really nice to talk to you all. I am a programmer. How many people here are programmers for a living? They check out code in the morning, check it in at night. Wow, okay, good, fantastic. How many people here are mobile developers? One person. That's even better. You might actually find this talk interesting. That's fantastic. So what we're talking about today, whoa, hey, liking that soundboard over there. You need a DJ scratch thing, whatever, a turntable, that's it. All right, so I'm Bill Sempf. You can find me at Sempf on Twitter if you're interested. That was freaky. So I'm a developer by trade. I have been the security guy on the developer team for about 15 years. I did my first application vulnerability analysis run in 2002 before there were any tools. I used like FXCop and WinDebug and weird things like that. So it's been a fun ride for a long time. But for the last year, so I'm a web guy primarily. Let's be straight about that. I do some rich client stuff, but I'm primarily a web guy. I've been an internet person since before there was a web. So how many people here know GopherScript? Oh, fantastic. Okay. I also know GopherScript. That's how old I am. So now you know for certain. But in the last year, I've been asked to do application vulnerability analysis on Android applications, which has been quite an interesting little trip for me. Not being a native mobile developer, I'm used to a web server generating HTML that's rendered by a browser, not a mid-thick client application on a device that's just speaking via the services. So it's been an education process for me, and I thought this would be a fantastic time to drop like all the tools that I've been using and the knowledge just kind of in one place, all the stuff that makes it possible for me to do the tests. We're not going to decompile anything. Well, that's not true. We are going to decompile a couple things, but we're not going to drop any elite O days or break Android or do anything super fancy here. I'm just going to show you the tools that I've been using and how to use them and the little caveats of getting them working to do vulnerability analysis. So real quick, what is vulnerability analysis? Vulnerability analysis is like pen testing, but it's not the same. Pen testers, generally speaking, are given a goal and have to do whatever is within scope to get to that goal. So, hey, get admin access on my servers, or get domain access, domain privileges, or get my Etsy password file, and then write a report to explain how you did it. So their job requires a very wide breadth of knowledge of lots of different things. Application vulnerability analysts, however, are given one application and are asked to find every problem with it that could be a security concern. So it's like really fancy QA, basically. In QA, you've got a test plan, you work the test plan. In vulnerability analysis, we know all of the potential vulnerabilities for applications. Application security, rather, is a solved problem. We know what's out there. We just need to accurately check for it, which requires a fair amount of knowledge of development and also of what the vulnerabilities are, and then a smattering of knowledge of general, like operating system security and network security and like that. That's what application vulnerability analysts do. So I mentioned that this is a solved problem. Let's see here. Yep. And it is. So there is a group called OAuth. It's the Open Web Application Security Project. And that group is all about distributing information about application security, specifically web application security, but they venture into mobile because mobile is not terribly unlike web because of its service-oriented nature. So one of the projects that OAuth does to help bring visibility to application vulnerability, or application security rather, is the top 10 list. You've probably all heard of the OAuth top 10, which is gathered from some 35,000 vulnerability analysis over a 3-year span. They judge how many different instances of each vulnerability you found, what the risks were, and then put them in order by what's most important to what's least important. Not every vulnerability, just the top 10, just to bring visibility. Well, you can't read this. It's okay. I'm going to read it to you. This is relatively new. It's the mobile top 10. So this is the same thing done to mobile applications. And that's where I started in all this. Like, I need to test for these things, but there's no good rules for testing for this. I needed to write some of them. So we've got things like M1. The number one vulnerability they discovered is improper platform usage, which is not a big surprise. If any of you here are pen testers or vulnerability analysts, you've probably discovered that if you test like a .NET application, the number one problem is caused by improperly using the .NET framework security features, turning off the cross-site scripting protection, for instance, or not properly using the cross-site request forgery token. Well, the same thing is true in Android, iOS, and BlackBerry and Windows Phone applications. People improperly use the platform. So that's something we need to do. We need to know enough about the platform to check and see if they're using it right. And that's not the easiest thing in the world. And frankly, even though it's number one here, it's probably my personal weakest piece because I'm not an Android dev natively. We'll get into that a little bit later and how that'll help you. M2, insecure data storage. This is by far the biggest one that I've found. People putting stuff in places they think is secure, but it's not. M3 is insecure communications, right? Calling a service tier, but not using TLS, or still using SSL v3, which is commonly known to be broken. Those kinds of problems, especially in banking applications, are a very big deal. M4 is insecure authentication. So this is failing to verify that the user is authenticated in every screen in the application, not realizing that users can move from screen to screen freely if they know exactly what they're doing. That's just one example. Session management weaknesses in general. M5 is insufficient cryptography. So they broke this out from insecure communication because there's a lot of encryption of data at rest. There's also a lot of confusion, just like we find everywhere else in the application space, between encryption and encoding. Developers think that encoding something with base64 or any other encoding is sufficient to prevent an attacker from modifying the information, when in fact that is not the case at all. Misunderstanding what a hash is for, things like that. Insecure authorization is M6, so not checking to see if a user has access to a given method in the underlying API because, well, they can't get to it from the UI, so it must be okay, right? We'll talk about that a little bit more later. Client code quality, which is it's a very big issue. Mobile applications are often developed under duress, like so many applications, and making pure and simple off-by-one coding errors in an application is really, really common. Code tampering, so failing is a negative, a reverse principle. Failing to protect yourself from the ability of a developer to patch and redeploy an application, which you can do in order to change the functionality of the application. Reverse engineering, which is the ability to figure out how the application works by looking at the source code, which you can do. And then extraneous functionality, adding in stuff that isn't actually needed by the application, then not putting any UI in, thinking that the user will never find it when really you can. So that's the mobile top 10. Now, just as an aside, if you're interested in mobile security, this is the 2016 list and it's in beta. So if you're interested in getting involved in some open source documentation work, OWASP is looking for some feedback on this. If you go to OWASP.org, OWASP.org, and click on the Mobile Top 10 project, you can go in and vote and give your opinion on these 10 items and whether you think they're the top 10 security concerns for mobile. So that's where I started. The next thing I needed to do is actually start to dig into the applications itself. And this isn't very, this is my list of all the stuff I'm going to do, so don't sweat this list too much. So the first thing I wanted to do was run an Android simulator, because in the development world, running on devices is a pain in the butt. So we try not to do it. Instead, we try to run in some kind of an emulator or simulator. In the security, same way. I can make changes to an environment. I can make multiple copies. I can make shadow copies and then revert to the state 15 minutes ago if I screw up the machine. That's what I wanted to be able to do. So I discovered this application called Genymotion. Genymotion is written by a bunch of Swedish developers, it is a wrapper over VirtualBox that specifically handles Android emulation. It is probably 10 times faster than the development kit that comes with Android, which we'll talk about a little bit later on when we talk about PC stuff. If you are going to do this, go get Genymotion. You can use it for free. It's one of those free for personal use things, but there's no way for them to check, of course. I did pay for the license because the software is that good. Also, I mean, when you write software for a living, you tend to pay for things because I want people to pay for my software, so you know, I pay for other people's software. That's the way it is. So this is a licensed edition. It looks a little, if you're going to do this yourself at home tonight, it'll look a little different than yours. So you can go and create a virtual device in any one of the Android versions that emulates an actual machine. Here's a Google Nexus 9, the tablet, HTC devices, Samsung. They've got all these pre-built ROMs out there. And this is already running, so I didn't need to start it. And here you are. So now we have a full-fledged Android application right here. Now, because I've got a touchscreen, I can actually go in and run it like a touchscreen. And it's very handy. So on my desktop at home, I'm obviously a Windows user. On my desktop at home, I have one of my monitors as a touchscreen, so I can easily get by and run through applications. So I will mention to you, if you do this, I highly recommend you set up a separate Gmail account to log in with. Make a fake account and let that be your test account. If you can, go and make a Facebook with it and a LinkedIn and a Twitter, and you can also use it for some social engineering stuff, which is awesome. It's like dual use. But you will find, like, this particular instance, I did not realize this when I started setting up the demo. This one is actually linked to my regular business account. My physical phone isn't. But so I'm sitting and working, and my Google chat messages from my wife started popping up on the test phone on my screen. I'm going, oh, that's not good. So don't make that mistake. Also, if you do something particularly extraneous in in an application that touches the actual Google account you're attached to, you don't want it to destroy your personal information. So please take a minute to do that. And I'll show you mine when we move to the physical phone here, assuming I have time. So what we need to do now, the most important thing that we need to do up front is we need to look at the communication between this Android device and its server, wherever it happens to be on the internet. That's the most important thing we need to do up front. It'll let us know what data is being transferred over the wire and how. If you've ever done web application vulnerability analysis, this is exactly the same thing. The web browser is now that Genymotion VM. Okay? So we've got the Genymotion VM, and we need to run Burp Suite. How many people here know what Burp Suite is? Okay, that's fewer than I thought. So Burp Suite is an attack proxy. It sits, just like a normal proxy, between one machine and another machine and lets you watch the traffic or modify it. Okay? In this case, it sits between the VM that we have running and whatever server it happens to be talking to. So the way it works is we have to set a proxy listener. Obviously, this is all on one machine, but pretend in your mind for a minute it's all separate machines. There's a server in the cloud somewhere. That's easy to forget about. There's a VM. Pretend like this Android device is actually a phone for a while, okay? Just a separate thing. This computer is sitting in between those two computers listening. So what we're going to do is we're going to set up a proxy listener that will accept any IP number coming in and that has a port number. And then we are going to go to our phone. Whoops, sorry about that. And we are going to oops, go to our connection, which Genymotion automatically sets up for you. It comes for free. We're going to modify it, and we're going to put in the IP number of this machine, port 8090, okay? We also need a Trust Burp certificate, which requires downloading the certificate and importing it into Android, which you can look up how to do if you want to do that. Then, if we were to run an application, like say, for instance, we go here and we find Insecure Bank, one of my favorite banks, right? And we go and we say log in. There's the post, the login. Now, there will be no response because I don't have the server set up for this because we're not actually going to break into applications. This is just going to be a tools demo. You'll notice there's a load of other stuff here. This is Android phoning home. Every application on this device is using port 80 or port 443 to communicate back. That's just how everything talks. Now, it is possible you're going to get an application that makes a binary pipe to some weird service and you're not going to be able to see it with Burp. Very unlikely, but possible. Pretty much everything is going to communicate with 80 or 443 and we're going to be able to watch it. So what if we only want to see our stuff? Well, you can right-click and say add this particular application to scope. Then go here, and these are the filter parameters. I realize it's small, I'm sorry. Burp only lets you make it so big, so you'll have to trust me on this. We say show only in-scope items, and it shows only those two requests that we've made from this particular instance. And that's how we scope out the test we're doing for a specific piece. So to give you an idea what this looks like if we get a more interesting application, let's say we can go and get, say, Hacker News. Load up Hacker News and try to tell it to refresh. Can I do that? Let's go to best. And we can hopefully make a new call. OK, there you go. Oops, got to scroll to the bottom. All right. And then here is Hacker News. Here's the request, just a get for /news. And there's the response. The response is coming back in JSON format. So this is where you're going to find most of your interesting stuff. Developers are used to calling services that were developed for other things, things that a web server would manage, so that they can take the web server, they can teach it to handle the JSON feed, munge it up, show it as HTML, and then send it over the internet. Here, however, we can see the actual JSON feed. We can see the original data. It's extremely likely the data that the developer did not intend to go over the wire is going to show up in here. Because the last time they coded against this in 2010 for their web application, it was all handled in their DMZ. This JSON never went outside their network. Okay? So this is the first place we look for information that's of interest to us. All right. Is there any questions on networking stuff? Sure. Absolutely. Yep. So the question was, I mentioned that we needed a cert. Is that because it's doing a man in the middle? And that is absolutely correct. And you can, if you're in a web browser, just say trust the certificate once, and it will forever. But in Android, it will ask you on every service call, and it's a pain in the ass. So I don't do it. You just import the cert instead. Now, if you import the Burp cert, that means that device is compromised forever. Well, until you remove the cert. While it trusts that cert, you cannot use it to do normal traffic. Another reason to have a fake account. So please do not do this on your regular phone, okay? Because there are attackers out there that use the Burp cert to do man-in-the-middle stuff for phishing attacks and whatnot. So please don't do that. So sometimes Burp gets confused about data calls. If that's the case, just use another proxy. There are many out there. Z-Attack Proxy is an OAuth project. It is free. It is wonderful. It is also written in Java. And it will do everything Burp does. There are some special attack tools that Burp has that are extremely powerful that Zap does not have. Because Burp has a staff, and it's $400 a year, and there's hundreds of thousands of people using it, so they have a budget. Zap is, oh, wonderful. Oh, yeah, it's going to blow up. This is Zap. Zap is an open source project that has 243 committers. The head of it is an OAuth member and project leader, Simon Bennett. He is employed by Mozilla to work full-time on Zap. So it's awesome, and it does some things very well. One of the things it does well is it doesn't get confused about traffic, whereas Burp does. It's almost got too many features. So if you have an app and you can't see the communication with the server, try another proxy. So once you have the services up themselves, you might want to actually build a test suite for the services. If you do so, strongly recommend Soap UI. It has an open source version, and I just realized it's probably going to show up really, really tiny because I haven't tweaked the settings for this mass. Yes, that's what I thought was going to happen. Sorry about that. Didn't think about that ahead of time. You'll just have to trust me. I can't even read that, so I'm sitting in front of the screen. So Soap UI is a QA tool for web services. It's called Soap UI because when it was written back in 2004 or whatever, SOAP was all there was. Now it very handily handles REST. So you can do things like put in REST endpoints. It will make reference calls to the REST endpoint and set up a test suite for you. Then you can proxy SOAP through Burp, exercise the API outside of the Android application, and find all the flaws that using the Android app wouldn't show you. Very powerful tool that way. So that's just a little aside there. Okay, what else we got here? Okay, so in order to be an effective Android tester, it helps to be an effective Android developer. So if you haven't yet, would strongly did I break it? No. Strongly recommend you go and download Android Studio from Google. It is free. There are tons of sample applications. Build the sample app and load it on your Genymotion test phone and watch it work. You can set up free services on Azure or on AWS or on Heroku and have the communication take place, and you can try all this yourself and see what the developer is faced with all their configuration options. Strongly recommend you do that. It is free. It is easy to use. The underlying development language is Java. Java is not hard. It's not Python, but it's not hard. And you can do some very, very cool stuff with it. So that's, and for some reason I've got a problem with this, so it's not gonna run, I don't think. Okay. So you can see how unbelievably slow this is gonna be. So, yeah, so learning the build process, learning the structure of an Android application will help you a lot when you get to actually decompiling the APK, which we'll get into in a minute. So Gradle's done, is it? Remember when I said this was slow? This is what I was talking about. All right, well, maybe it'll pop up eventually. We'll keep working for a little while here. All right, what else we need to talk about here? Oh, ADB. So, once you have, can I make this bigger? Well, that's better. Once you have your Genymotion VM running, you can use the built-in command line tools to connect to it. Genymotion ROMs are rooted by default, so you have complete control of the Android phone as a Linux box, which is what it is under the covers, right? So you can use ADB. ADB is super easy to use. You can just download it from Google, put it in your C drive, in its own little folder like that. It's 4 files. Super easy. Add it to your path. This works in Linux too. I didn't mention this before. I'm going to back up for a second and say, the first thing I did before any of this, so rewind quickly to the beginning of the talk. The first thing I did is start all this under Linux, because I thought Android's Linux makes sense. And I've got a machine just like, well, not just like this, but I have a machine with a touchscreen that's Linux. And it's my main test machine when I'm testing applications. And I started this process of building out this test lab for Android. And it was a disaster. There aren't any tools. There aren't any. There isn't anything that runs on Linux. All of this is based on what modders use to do rooting and modification and theming of applications, and all of them are 14 years old and they all use Windows. You laugh, but I'm not kidding. It's true. They're using mom's old Windows laptop to do this work, and the software they write is all Windows software. Android Studio doesn't run on Linux for crap. ADB works kind of. The other tools I'm going to show you, there aren't Linux versions. So if you're a Mac user or a Linux user, I recommend doing all this on Windows. And what's more, it can't be a Windows VM because Genymotion has to run on the metal. So it's a Windows world, and I don't know, I mean, for this testing, I don't know why, but it is. I'm not a Windows fanboy, but I tried it both ways, and this was the easiest. So there's ADB. So we can say ADB devices, and it'll tell us what's attached. That's our Android application, our Android VM. So ADB is very powerful. It has lots of cool features. As you can see, there's all kinds of things. You can move files back and forth. There's all kinds of networking tools. There's push that moves the files back and forth. Devices, you can connect and disconnect via IP. But the thing that you're going to find that you use most of all, whoops, I wish I hadn't done that. You're going to find most of all is push, pull, and shell. Now we're logged into that Android VM. Done. There's all the files. That's it. It's being the end of it. Yes. I don't know. Can I? Font. Anybody see it? Glass tab. Oops. Want that. Screen text. White. Okay. Oh, looky there. See, I'm learning stuff. Normally I work in an IDE rather than a command prompt. So if we look in the SD card folder, for instance, there's the stuff you expect to find in your SD card folder, right? Done. It's fantastic. So what was I going to talk about? Yes. So it comes pre-connected. The Genymotion VM will already be connected to ADB. You won't have to touch it. Honestly, I'm not sure why that happens. I haven't figured that out yet, but it's true. You just spin up a new VM and ADB will just find it like that. You don't have to do any Connect stuff. Because honestly, Connect is sometimes a little janky. It's hard to figure out what's going on, especially if you have an unusual network situation and whatnot. Yeah, so it's just a Linux box, right? Frankly, probably most of the people in this room know more about stuff you can find in here than I do. But let me show you one thing. Oops. Data is where everything is going to save its settings. So you install the app, you go to data, and then you get a shell. You ADB pull, com.svox.pico. Oh, sorry. And you remember the last trailing slash. There's no files there. It was the shortest one. That's why I grabbed it. And then you get an idea of what the settings are on install. Then you exercise the application on the phone and do it again and compare them. Yes?
But this should work with just about any ROM that you would download also, right? From an emulated image?
Well, that's what we've done. That's what Genymotion's making it easy for you to do, yes. If you want to do it manually, that's fine. But Genymotion has the ROMs preset, so that's what. The question was for the recording, this will work with any ROM that you have downloaded, and yes. If you want to actually take an image of a real phone, and you could set it up as a VM, and it would work the same exact way, yes?
Can you compare this to ADIO?
No, because I don't know that, sorry. I am not an expert. This is the stuff. In fact, if afterwards when we're done, if I'm completely wrong here and you have a much easier way to do something, feel free to come up or yell it out at the end and tell me where I got something completely wrong. This is literally just my original research and nothing else, nothing more, beginning and end of that. So that's what we want to do. We can log in with shell. We can look around in the OS. We can so we can go look at, for instance, we can say cd to io dots that, cd to shared prefs, and then we can ls that. And we got local prefs.xml. Think there might be something interesting in there? Now in this particular application there isn't. I didn't want to go break into anything because that's just rude. I actually, if you are bored one day and you're curious about Windows security, I did a talk at Black Hat Europe, I don't know, 2011, about Windows 8 security. When Windows 8 was brand new, this is before it dropped, so it might have been before 2011. I don't remember, but it's on YouTube somewhere. I actually showed like security flaws in the Windows 8 store apps because they're just JavaScript. You can just go look at them. And I actually got a phone call from Microsoft. So I'm not doing that again. We're just going to talk about tools today because Microsoft was nice. I don't think Google will be. So we can do, well, there's nothing interesting in there right now, but there might be something after we exercise the app for a little while, right? And that's what you want to do. You want to install the application, get an ID, take a snapshot of its data profile, exercise the application, take another snapshot, compare the two, find out what it changes about the OS. Now, sometimes applications have ability to look at things in other places of the Android OS. You might have to go elsewhere in the Android OS to look. And we'll look at that when we talk about decompiling here in just a second. Downloading stuff. You can copy the host. I showed you that with ADB pull. Oh, yeah. So I will show you this when I get to this phone, but there is a tool called APK extractor, and you can actually go and get the .apk file, which Android does not allow you to do by default. But because it's a rooted phone, you have more control. So APK extractor will actually get the APK for you. You can ADB pull the APK file. You can ADB pull the APK and download it to your local machine, and then look at it. So this is where we have. Well, let's stick with the script. So no, I changed it. I'm doing on time. Good. Okay. So once you have the APK, you can do things like run scanners on it. Now LinkedIn wrote a scanner that they then open sourced called Quark. I don't know what it's called. I've never said it out loud before, I don't think. What's this? Whatever it says there. Quark. Shoot, I don't know. But it's a scanner, and it's written in Python. And it's stupid easy to use. Nope. Oh, that's good, Bill. You know, everybody's favorite programming language, Python. It's all menu-driven. It's like, who here's used SET, the social engineering toolkit? Isn't that awesome? Dave Kennedy rocks. He is not a programmer, though. The app works great. Have you ever looked at the code? Oh, my God. It's terrifying. Yeah, do not use that as an example for how to architect Python apps. So you can just go in here and say, I want to use an APK. I'm going to provide a path, and then I'm going to remember where that path is. Oh, okay, I should have done this before. So many things I prepped. I didn't think about this. Oops. Let's see where this is. Oh boy. Well, you might just have to take my word for it, because we're running a little behind anyway. Okay, I don't remember where it is. Okay, so anyway, this is just, it's a scanner, it's a code scanner, right? It's going to look for common flaws in Android applications for you. And it's blindingly easy to use, and I have a APK on here somewhere to test it with, but I'm running a little slow anyway, so we won't play with it right now. And it just sits and goes, and then gives you this HTML report you can like throw in your evidence folder. It's fantastic, and it's free. And LinkedIn people wrote it, and even though LinkedIn's a little bit screwed up of a company, the security guys are super nice. And one of them is in Columbus Locksport, and he's awesome, and he pointed me to this. Highly recommend it. The iOS tool, not so wonderful. The Android tool, 2 thumbs up. So you can do that. So what else can we do? You know, I'm not sure if I'm going to need this later, so I'll just leave that running. So we have the APK. What else can we do? Well, there's a couple things you can do. So here's our APK. As it turns out, an APK is just a zipped up folder. You can change the directory, change the file extension to zip, expand it, and there's everything. Now, some of it's compiled, some of it's in binary, some of it's hard to read, some of it isn't, but it'll give you something to sit and poke at, which is awesome. There are tools out there that will help you reverse certain pieces of this, look at things. You may have decompilers of your own that would work at stuff. Some of them are just text. For instance, this is the manifest. This is all of the things that the application uses, the list of pieces of the Android OS that it pulls in for use. Very interesting information. It will also teach you what features of the Android OS, what is allowed to use. So that's very useful, because if it has access to special environments within the Android OS, or special directories, or the SD card or whatever, all that'll be in here, so that's very interesting information. But there is even a better way to do this, and that is, why isn't it on the list here? It is not running. Virtuous 10. This is Virtuous 10. This is the Zen example of why using Windows is better for this kind of testing than using Linux, even though Linux is far superior for most security testing. For this kind of vulnerability analysis is better. Virtuous 10 is one of these pieces of software written by some kid initially, he's not a kid anymore, to do modding, theming of Android applications. It is extremely rich and powerful, and it does full decompilation all the way back to the Java of an APK, even if it's been obfuscated. However, it is a pain in the butt to configure, and between last week and this weekend, while I was on vacation for that week, a Java update came through for this machine and borked it. And if I try to run this project, it blows up. And I could not get it fixed between when I got back yesterday afternoon and today, so I can't show you how awesome this software is, and I'm very sorry. But go get it at Virtuous 10 Studio. Go get it, install it, work through the config, and then take apart an app. You can quite literally change the way the app works, change the Somali files that are underlying the basis of the application, the way it interacts with Android, change the way the app works, patch it, and put it back on the device if it's rooted, and run it the way you want it to be run. So think about that. If you work in the security field and your developers are writing applications and they're saying, well, no, I've got the app configured so it can't do that, remember that an attacker can change the way the app works. Very, very key. And this is the tool they use to do it, and I'm sorry I can't demo it because I'm apparently so there's that. Okay, so once we have it downloaded, what do we look for? Well, there's a list. Where the heck is it? Oh, that's going to be interesting. I don't want to do that. All right, well, that's all. Ooh, okay. Oh, dude. Oh, it's one of those days. All right, it's gone. So I don't have the file for some reason. It used to be here. I must have gotten rid of it. Anyway, there are in the OWASP mobile testing piece that I mentioned earlier that has the top 10, there is a collection of features that you can, a collection of common bugs you can look for. Oh, wait, I know where to find it. Give me just a minute. I'm going to move to PC screen only for just a second, because I'm going to get it out of the live sheet. Okay, I promise I'll be right back. I know exactly where to get it from. One moment, please, and we'll get that. Hang on. All right. Go here. Oh, look at me. I rock. Copy that. Say new. Paste it. Spread this out. Spread this out. Okay. Have to deal with a little bit of formatting. That's okay. I can do formatting. Are we back? Okay. So I mentioned that vulnerability analysis is a lot like QA work, and it is. And you have to have a test plan. And so I have a test plan, and I'm going to put all this up on my blog at sempf.net next week sometime, so you can take a look at it. But once you have the source code in Virtuous 10 or using APK tool, or if you search for Android decompilation, there's a billion tools out there. Virtuous 10 is just the best one. Once you have it extracted, you can go and look for specific things. So let's look at the property files. Right? Let's look. Here's some actual keywords you can search for, and then, is there SD card storage? Is there stuff that you adhere? Is there something in the manifest file for write external storage? Remember I mentioned, does it have access to do certain things within the Android OS? Things you need to look for. Look for the button tag, right? This is just like clickjacking, looking for pieces. Look for JavaScript interfaces, right? Look for comments, just like you would in a web application. All of these pieces, this is just the test plan that we're going to work through once we have access to the underlying source code. So there's a lot we can do. We can watch the communication with the server, and we can look at the actual code of the application and make decisions about that. So, I mean, really, the only thing we don't have is what's happening between the service tier and the database, well, unless you can get into that machine, which hopefully you can't. We have a lot of access. So it's very easy to go and find the problems that are out there. It's just about using these tools to get the job done.
Where are they getting
Yeah, because they compile in debug mode and the comments stay. Yep. The question was, why are the comments still there? Compilers should get rid of them. Well, if you compile in debug mode, it won't. And there's something like 14% of the apps in the store are still in debug mode. So yeah. I'm going to, bear with me for a second, I'm going to save this for later. Okay, so where are we now? Okay, so the last thing, there might be a case where you need to run on the metal, okay? Specifically, if you have an application that uses Bluetooth or the camera or the any other hardware aspect of the phone, Genymotion can technically emulate those, but it sucks, like real bad. So don't even try. If it's just a straight, data in, data out application, you can run it in the emulator. If it uses Bluetooth or the camera, or requires a chip or anything like that, requires like a chip or anything like that, uses the SIM card, for instance, you're going to want a device. So the best thing for you to do, if you're going to do this, if you have a couple bucks, is go buy a OnePlus One. So OnePlus is a Chinese phone manufacturer that is making flagship level phones equivalent to the Nexus devices for half the price because they're not being stupid. I mean, the Android prices are getting jacked up because Apple is now a fashion company. And so you're paying, if you go buy the latest Samsung, whatever, blah, blah, you're paying about twice what the actual components are worth. The OnePlus isn't doing that. So this, I'll take it out of the case for a second so you can, for those of you who are close by. It's one. It's a very, very nice phone. It comes with Cyanogen by default, and OnePlus provides the root ROM if you want to root it, which you will have to do. I'm not going to talk about rooting in this talk. If you can't look up the rooting stuff, then do Google push-ups for a couple hours, and you'll be okay. So what you do then is, this is the phone you put your fake account on. Well, you should do it in your VM too. And this is this is my fake account. So how many people remember when Gmail first launched and you had to have an invitation to get a Gmail account? Okay, so I was like the 1200th person to get an invitation. And I got solution@gmail.com. Do you have any idea how many people use that? What? I broke it. Anyway, do you have any idea how many people use that account by accident to sign up for things like Facebook, LinkedIn, and Twitter? Well, at least one. So I have over time collected these Gmail, Facebook, Twitter, all these other social networking accounts that have access to, so I have fully populated accounts on all the social networking stuff from some guy in Ghana, and I really broke this somehow. This is not cool at all. Somebody messing with my network connection? You've got your phone out. It's probably you. He's like, what? He's not even listening to me. Hang on for a minute. I'll see if I can get this back up and running again. Still connected. Anyway, I can just talk about this. So once you get this done, you get a OnePlus and install Kali NetHunter. Okay, it is a Kali ROM for your phone. It installs right on top of Cyanogen. It will not replace all your stuff if you're already rooted. Remember, when you root the phone, you will clean it. So root it first, then set up all your account stuff, or you'll have to set everything up again. All right? Install Kali NetHunter, and it comes with all these awesome tools, which I would show you if my thing would work. Here, air mirror. Huh. All right, well, I'm running out of time anyway. Wow, that's really weird. I could find my cable, I guess. So NetHunter comes with a whole, I don't need to hold it anymore, you can't see it. It comes with a whole host of tools that are awesome for using the device as a pen testing device. So you can attach to wireless networks. It has Nmap, stuff like that. It's really very powerful, but it has a whole host of features to help you look at the apps themselves, like file managers that have root privileges. So if you want to look at stuff on the phone as it's happening, you can, rather than having to use ADB on a workstation. Very, very handy, that. So I would recommend using both, having both a physical device and the virtual device, both set up with your test Gmail account, and all ready to go there. What did I forget to talk about? Let me look here. Right, yeah. So you set up the local proxy. You can run it through Burp with the local proxy, just like we did with the VM. File manager, Kali NetHunter talked about that. The APK extractor I mentioned earlier. And yeah, I think that's about it. So those are the tools that I'm using right now to do vulnerability analysis for Android. I have, of course, the problem with vulnerability analysis is you really don't know how successful you've been until somebody breaks into it using something you didn't know was there. So far, that has not happened to me, so I like to think that I'm being relatively successful at it. I haven't failed to turn in a report on an Android application without at least several findings. I don't remember what the lowest one was. There's a lot of stuff out there, but you need to educate yourself in the platform a little bit before you get started, and then hopefully this set of tools will help you out. And that's all I've got. So if you guys have any questions, we've got about 5 minutes left, and other than that, thank you very much for having me out here. I've been trying to come to this con for like 4 years, and it always intersects with something bad, and I'm really glad I got a chance to get out here. Go ahead. Yeah, go ahead. That's a great idea. I should do exactly that. I hadn't even thought about that. Yes, I will probably. The question was, are there any plans to incorporate my test plan into the OAuth stuff? And I hadn't even considered it. I probably should do that, yeah. I probably should. Yes?
The webpage you mentioned earlier that you were going to post things.
So she asked about the web page. Yep. That's my blog. Right there. That's where it'll be. Yes? He mentions that the Chrome browser has a plugin for downloading the APKs directly. I had no clue. Yes, it will. So that's super easy, yeah. I mean, geez. Any other thoughts? All right, I'll be around, well, till the end. So if you have any questions, feel free to come grab me, Bill Sempf. And thank you very much for having me. Have a good rest of your con. Thank you.